Good morning, Bobcats. This is Miss Gorman. Let's get started on today's lesson. Today's lesson is greatest common factor. We're still in chapter 0. Our lesson is chapter 0.2b. The objective today is students will be able to determine the GCF. GCF stands for greatest common factor between two or more numbers. Why am I learning this? This will help us reduce fractions. All right, let's talk about some strategies, some prior knowledge that we already know. The last lesson was on divisibility rules. So being able to look at a number and using our rules to determine what numbers can divide equally into that number. We also know how to divide whole numbers and we know how to factor numbers. All right, let's get started on our first problem. Our first problem is a word problem. Gideah is planting tulip bulbs in a flower garden at her plant nursery. She has 36 tulip bulbs that she would like to plant. She wants to plant them in rows of equal sizes and use all of her bulbs. How many rows of tulips can she plant? List all the possibilities and combinations by organizing your numbers in a table and explain your answer. Miss Gorman is really tripping up on her words today. Sorry, you guys. Okay, so for this one, we are going to build a table. You may pause this at any time. Remember, anything that I have written on my screen, you need to write on your paper as well. All right, so we are going to make a table chart to help us understand and solve this problem. So our table is going to be a T-chart table. The first column is going to have number of rows. The second column is going to have number of bulbs. What we're going to do is factor the number 36. Find all the numbers that you can multiply together to equal 36. So let's see. I know that 1 times 36 equals 36. I know that 2 times 18, 3 times 12, 4 times 9. Now what about 5? Well, it doesn't end in a 0 or a 5, so 5 is not a factor. 6 times 6 is 36, so 6. And now we can have 7. Does 7 go in there? 7 does not. Does 8 go in there? 8 does not go into 36 equally. So now we're to 9. Does 9 go into 36? 9 times 4. So it's the opposite. We said that 4 times 9 equals 36, but 9 times 4 also equals 36. 9, does 10? No, it doesn't end in a 0. Does 11? No. What about 12? Well, we see up here that 12 times 3 equals 36, so 12 does. 12, 13, no. 14, no. But we're missing, over here we see 18 and 36. So I have 18 times 2 equals it, and I'm going to continue my T-chart over here. I have one more, and 36 multiplied by 1. All right, so these are all of the factors of 36. So let's reread our question. Our question states, how many rows of tulips can she plant? List all the possible combinations. So we did that. Now, by organizing your numbers in a table and explain your answer. So we did that, but up here it says she wants equal sizes and use all of her bulbs. So which one has equal? Equal number of rows and equal number of bulbs. 1 and 36, those are not equal. 2 and 18, that's not equal. 3 and 12, that's not equal. 4 and 9, that's not equal. 6 and 6, so we would have 6 rows of 6. So the answer would be 6 rows with 6 bulbs in each row. All right, so we have another word problem. Let's read this one. Gideon also has 24 daffodil bulbs, so 24 bulbs, that she would like to plant. Similarly, she wants to plant the daffodils in rows of equal size and use all her bulbs. How many rows of daffodils can she plant? List all the combinations by organizing your numbers in a table and explain. So this is similar to the last one. I'm going to give you guys some time to go ahead and do this, and I'm going to do it on my screen. All right, so I have my numbers of rows and numbers of bulbs. We're just going to go ahead and factor this one out, and then we're going to move on for time. So let's think about all the factors of the number 24, since that's the number that we are working on. So 1 multiplied by 24 gives us 24. 2 times 12. 3 multiplied by 8. 4 multiplied by 6. 5 doesn't go into it. 6 multiplied by 4. 7 doesn't go into it. 8 doesn't go into 24 evenly. 9 doesn't go into 24 evenly. 10 doesn't go into 24 evenly. 12 does. We said right up here. So 12 multiplied by 2 gives us 24. And then, of course, our first one, 24 multiplied by 1. So let's think about all the combinations. How many rows of daffodils can she plant? Let's see. 1, 2, 3, 4, 5, 6, 7. There's 7 different combinations. All right, let's move on to the next slide. So here is another way to find the GCF. So it says use a Venn diagram to find the GCF of the pair of numbers. So this is 2 numbers. So we're going to factor the number 30. We're going to factor the number 30, and we're going to factor the number 36. So I know that a Venn diagram, anything that is in between both circles means that both numbers share this. So 1 is a factor of both of these numbers because 1 times 30 gives us 30 and 1 times 36 gives us 30. All right, what about 2? Does 2 go into 30? 2 goes into 30 15 times. So 2 and 2 goes into 36 because 6 is an even number. 2 goes into 30 15 times. 2 goes into 36 18 times. All right, moving on to 3. 3 goes into 30. Does 3 go into 36? Let's think about our divisibility rule of 3. 3 is if the sum of the digits is divisible by 3. 6 plus 3 gives us 9, so it is divisible by 3. 3 goes into 30 10 times. 3 goes into 36 12 times. Does 4 go into it? No, but 4 does go into 36. So 4 times 9 gives us 36. Does 5 go into either of these? Oh, 5 goes into 30. 5 times 6 goes into 30. Okay, so we know 5 times 6. All right, let's think about 6. Does 6 go into 30? Well, we just said 6 does. Does 6 go into 36? Yes, 6 goes into 36 6 times. So 6 is a number that they both share. So I need to erase it out of this one because they both share it. So it goes in the middle. All right. GCF means the greatest. The greatest. Greatest. Greatest means biggest. So what is the greatest common? Remember, common is anything that's in the middle of these circles. The greatest number that both of these numbers share. Well, we already wrote them in numerical order. So the biggest number that both 30 and 36 are divisible by is 6. So the answer is 6. The GCF equals 6. Great job. All right, let's read the directions. 7 says make a list of factors to find the GCF of each pair of numbers. So we're going to go ahead and make a list of 16 and 56. I'm going to start with 16 over here. I know that 1 multiplied by 16 gives me 16. 2 multiplied by 8 gives me 16. 3 doesn't go into 16. But 4 multiplied by 4 gives me 16. 5, no. 6, no. Nothing goes into it. 7, no. 8 we already have. All right, so it looks like we're done with 16. Now we're going to move on to 56. We're finding the factors of 56. 1 multiplied by 56. 2 goes into 56. I know this because it ends in an even number. So 2 multiplied by 28. If I didn't know that, I could go off to the side and divide 56 by 2. 2 goes into 5 2 times. 2 multiplied by 2 gives me 4. 5 take away 4 gives me 1. 16. 2 goes into 16 8 times. All right, so 2 multiplied by 28, 4 multiplied by 14, and 7 multiplied by 8. So now we need to figure out what the GCF is. We have listed all of our factors of both 16 and 56. Now we need to figure out what's the biggest number they share. Well, they share 1, they share 2, they share 4, they share 8. Do they share any other numbers? Or do they have any other numbers in common? No. So the GCF is 8. All right, let's move on to our next one, which is 25 and 50. All right, so 25. 1 times 25. And the only other one is 5 times 5 gives us 25. 6 doesn't go into it, 7 doesn't go into it, 8 doesn't go into it, 9 doesn't go into it, 10 doesn't go into it. Let's move on to 50. 1 multiplied by 50, 2 multiplied by 25, and 5 times 10. All right, so we're figuring out what the GCF equals. Well, the biggest number that both these two numbers, 25 and 50, have the same factor, the biggest factor they share is 5. Oh, I'm sorry. Miss Gorman made a mistake. I see a bigger number. What's the bigger number? The bigger number is 25. I'm sorry. Even I make mistakes. So the GCF equals 25. That's good. That error is one that you guys can learn from. So even though they do share the number 5, it's not the greatest. It's not the biggest number that they share, that they have in common. So the GCF is 25 because they both share the factor of 25. So that's a good learning moment. All right, we are moving on to our last skill for today. The directions for number 10 says find the prime factorization for each number in a given pair. Then use the prime factorization to find the GCF. So we're working on 12 and 56. So prime factorization means I'm just breaking this number apart. So I know that 3 multiplied by 4 gives me 12. 3 is a prime number, so I can't multiply anything except for 1 times 3 to get to 3, and we don't need to worry about anything times 1, so we're moving on to the number 4. 2 times 2 gives us 4. So now we're done with this tree. We're ready to move on to 56. All right, let's think about our factors, our numbers that we can multiply together to equal, numbers that we can multiply together to make 56. So 7 multiplied by 8 gives us 56. 7 is a prime number. I can't break that down any smaller. But 8 I can break down to 2 multiplied by 4. I can't break down 2 any further, so I'm going to break down 4. 2 multiplied by 2 gives me 4. So now I need to figure out what my prime factors of each number are. So I'm going to go back to my number 12, and I can say that 12 is 3 times 2 times 2. Now we can check this out to make sure that this is true. What's 3 times 2? 3 times 2 gives me 6. And 6 times 2 gives me 12. So that does equal my number that I'm working with. All right, now we're going to do our number 56. 56 is 7 multiplied by, by 2, and 2 again, and 2 again. We can check this out to see if it's true as well. All right, so I'm going to see if this is true. 7 times 2 gives me 14. 14 times 2 gives me 28. 28 times 2 gives me 56. So this is true. My work is correct. I'm going to go ahead and erase that. Now we're looking for all the sets or all the numbers that they have in common. I'm going to switch my color so we can see this easily. Well, I see a 2 over here and a 2 over here. I see a 2 over here and a 2 over here. There's a 2 over here but not over here. A 3 over here but not over here. So they don't have those numbers in common. So I can say that the GCF of these prime factorizations would be 2 multiplied by 2, which is 4. So my GCF equals 4. So let's think about the things that we learned today. Today we learned how to find the GCF. So find the GCF. We learned that through making a factor tree, so writing like 12, 1 times 12, 2 multiplied by 6, 3 multiplied by 4. We learned through our Venn diagram, and we also learned by building our tree. So, for example, if we were to do 12, it would be 2 times 6, and then breaking the 6 down to 3 times 2. So we learned different strategies or different ways to find that GCF, the greatest common factor. Thank you. If you have any questions, please contact me.